All right. Well, let's do a quick little video on how to generate a solid, find the bottom of a solid when revolving around a y-axis. So how does that work? As you can see in the question here. Well, I have a little example here. What we have is a region bound by the y equals um, 2 lines. So here it is right there. We have x equaling 0, so horizontal, or sorry, vertical line right there. And then we have a line x equals 3y over 2. Now, in all my other videos, we've been revolving around the x-axis. Well, now we're revolving around the y-axis. So what's happening is we are revolving it around this way. And so you see, we revolve something around this way. We are taking this little triangle and revolving around a circle. And as we did before, we realized this is going to be a cone. It's going to be a cone. So how do you revolve something around the y-axis? Well, essentially revolve it around the y-axis the same way you revolve it around the x-axis. You have to identify the radii that you're going to be using. So in this case, when we have this right here, we start at our axis of rotation and we go to the farthest point, and that's going to be our big R. We know this is flush to here, so we're only going to use one. We have one radius, so if we were to do this, we're going to integrate. All right, now we're looking at the y-axis, so everything has to be in terms of y. Why? Because we're rotating around a vertical axis. So whenever you're rotating around a vertical axis, and y is a vertical axis of rotation, we're going to put everything in terms of y, unless you use something called the shell method, but that's in some other videos that I've done. And so right here, we're going to figure out what this R value is. So we start here, and you're going to go right to left, right to left. And so what is this value? Well, it's going to be 3y over 2 minus this right here, which is 0, okay, which is 0. And so right there, we can go from here, 0, to, it appears 2. We are rotating, so once again, what's our cross section? All right, our area of our cross section is a circle, so pi r squared. And so I'll put a pi over here. Our r, big R we're talking about here is going to be 3y over 2, that quantity squared, dy. And that's how we can figure that out. We could simplify this if you want. All right, and we're just going to solve this real quick like a fox. So I'm just going to put 9/4 on the outside. There's 0, 2 right there. We'll have y squared dy, pi and then 9/4. So go over here. That's going to turn into y cubed over 3. And we're going from 0 to 2. Plugging those in, put 9 and pi over 4 right there. Times plug the 2, be 8/3. Minus plugging the 0, 0. And so what we have here, multiply those through, we'll have 2 and 3. And so we'll have 6 pi as our answer. Now, let's say I change this up, and let's just say I change this problem. So instead of rotating around the y-axis, let's pick a different horizontal axis. Let's say we want to rotate this around the x equals negative, let's just go 1, 2, 3, 3 line. So x equaling 3. So let's just go, all right, x equaling 3. All right, that line right there. I like making sound effects when I do those lines. All right, so we have this line. Now, once again, it is a vertical axis of rotation. And it's going like woo, 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 woo here. And so if you see this, you kind of notice that, all right, this is going around like so. And so what we actually are creating is, it appears to be some sort of cylinder, but we're taking a cone out of it. Ah, interesting. So how do we do something like that? Well, if you watched in previous videos, okay, because we're doing this, we actually have 2 different axes of rotation. All right, starting here, we have one. We have a big axis. All right, we'll call this our big radius, big R. And then we have itty bitty, all right, our smaller r, and that smaller r is being taken out. This is where we're going to use the washer method. Once again, we are rotating around a vertical axis, so everything is in terms of y. And so here we're going to integrate from 0 to 1, 2, 3, 0 to 3. We'll have pi, but now we're going to have two circles because we have the big circle on that side. So what's that radius length going to be equal? 1, 2, and 3. So we'll have 3 squared. All right, so big R is going to equal, if we take this 3 minus 0, which equals 3. So we'll go 3 squared minus this little r, and little r, if you notice, starts here. So go right, all right, which is 3 minus this line right there, which is 3y over 2. And so we'll have this value of 3 minus 3 halves of a y squared dy. All right, that's a square right there. And so that's how we can use what is known as a washer method to help us identify and solve this problem. All right, so this is if we're rotating around y, or sorry, not y, x equaling 3. All right, 3. Now, if we change this up one more time, let's say we go to a different spot. All right, a different spot. And let's just say we have this over here. Let's just say we go to the negative. Let's say we have 1, 2, 3, 4. We'll go over here and we'll go x equaling -4. All right, x equaling -4 is our axis of rotation. Well, how does this change? Well, starting here, and we're going to take this value right there. What do we have? Well, we have a big R, and we also have a smaller r. Okay, because we're stopping here, right there. So we're taking out this one part because we're stopping at this 0. And then we have our big R, all right, which is going from axis of rotation all the way farthest value. So once again, this is our small r right there. So what are these r value lengths? Well, our big R, right minus left, is going to be 3y over 2 minus -4, which will be +4. Little r from here to here, well, we're going to start at 0 minus our -4, which makes it +4, and that equals 4. And so really what we have here is where we're integrating from. Well, once again, 0 to 1, 1, 2, and 3. All right. Oh, sorry, not 1, 2, 3. 1 to 2, 1 to 2. And I think I screwed up in this over 1 because when we're doing this right here, we're still integrating right there. So we go from 0 to 2. I apologize. Hopefully you caught that in my one thing. So if you said, hey, he doesn't know anything, I'm sorry. All right, but in this case, we're going to have our big R. Big R is going to equal 3 halves of y plus 4. We're going to square that because it's a circle, minus our other one, which is going to be 4 squared, right, and our dy. Okay, be careful with your limits of integration and make sure you keep those in terms of y and not x, as I was just about to do that right here, so I apologize. All right, so once again, 3 different examples using in terms of y. We always do it in terms of y if we're going around a vertical axis. Vertical axes. I always want to find, if you're doing washer, big R minus a little r. Little r is the values that aren't being included, and then big R is that farthest length from the axis of rotation to the actual curve itself. All right, well, I hope this helps you out in understanding how things work and how to rotate solids or areas, regions around a vertical axis. All right, well, good luck and God bless in the rest of your problems.